In the previous video, we learned about some polynomial terminology and also how to add and subtract polynomials. In this video, we're going to learn about how to multiply polynomials and some special products that can speed up our multiplication process. So let's start with generalizing the multiplication so to make it easier. I'm just going to write down two polynomials and we're going to try multiplying them. So our first polynomial is ax plus b and our second polynomial is cx plus d. And we want to multiply them. And we use a process to multiply them called FOIL. So it stands for first, the F stands for first, the O stands for outer, the I stands for inner, and then the L stands for last. Okay, so let's first do our first. So the first terms in both the polynomials, we multiply those. So that's the F in the FOIL. So we have ax times cx. And now let's do our second step, which is the outer terms. I have both of the outer terms. This is an outer term and this is an outer term. Like outer, like in respect to like the position. So ax times d plus, and now we do our inner. So our two inner terms, which are these two, b times cx, and then our last terms, which are, this is a last term in the polynomial, in this polynomial, and then this is a last term in this polynomial. So I would have the b and the d. And as you can see, this gets every combination that you can multiply by, so that's why it works. So, and then let's just break this down. So we have acx squared, since if you multiply these together, the a and the c remain, but the x, it's x times x, so then, and we know x times x is x squared. And now let's try that. So there's no terms we can simplify further, so it's axd for the outer or green. For the orange, it also just remains as bc, like there's no, you can't simplify it, so it will remain as bcx. And our last term is remaining as bd. And if we want, we can write it like this. So acx, and then you can factor out the x in the middle two terms. So I want to factor out that one and that one from those two terms. So I have x and then ad plus bc, and then I still have the bd. So yeah. Now let's try using this FOIL process. So I'll give two polynomials. So I'll give x minus 3 and then x plus 3. So FOIL is first, outer, inner, last. So I'll do my first. So x times x is x squared. Those are my two first terms. Then I'll do my, here I'll color code this to make it easier. So I'll do my first terms, x and x, which is x squared, x times x, x squared. Then I'll do my outer terms, x and 3, so that would be 3x. Then I'll do my inner terms, which are minus 3 and x, so minus 3x. Then I'll do my last terms, which are minus 3 and 3, so which is minus 9. And we can simplify this by canceling out the like terms, or adding the like terms. So these two cancel out in the middle. X, and we're left with x squared minus 9. Okay, so that's a process of using FOIL, and this is actually one of our special products formula. The special product is that it's called difference of two squares. Here, I'll write it. Difference of two squares states that x minus a times the polynomial x minus a times the polynomial x plus a is equal to x squared minus a squared. So these two polynomials are called conjugates, and they're the same variables, but they just have a different operation in the middle. So as you can see, the operation in the middle over here, that's a minus, and the operation in the middle over here is a plus. So yeah, if you multiply two conjugate polynomials, which are two polynomials with different signs in the middle, you would get, with the same variables, you would get a difference of two squares, x squared minus a squared. And we can see that over in this example that we did over here. We did x minus 3 and then multiplied by its conjugate x plus 3, and we saw that that got us x squared and then minus a squared, but here a was 3, so it would be minus 3 squared or minus 9, which we got. Okay, yeah, that's one of our special products. Now moving on to another important special product is squares. They're called perfect squares. So perfect squares state that if you have a polynomial, let's say x plus a, and you square it, it should equal x squared plus 2ax plus a squared. And we can just show that using a quick example. So let's say I have x plus 7 squared. That would just mean the same thing as x plus 7 times x plus 7. And then using FOIL, we do first x squared, then we do outers 7x, then we do inner 7x again, and then we do last 49, or 7 times 7, which is 49. And we see if we simplify it further by adding the like terms, x squared plus 14 plus 49. So we can see that if we, instead of using this process, and if we just use the perfect square formula, we would have gotten the same answer. So let's try using the perfect square formula. So x plus 7 squared, and we know that the formula states that it should be x squared plus 2x plus a squared. So our first squared is x squared still, plus 2 times a. Here, in this case, a is 7. So 2 times 7 times x, which is x still. So x. And then plus a squared. A is 7. So 7 squared is 49. That x squared plus 14x plus 49. Plus 49. So we can see that using FOIL and just using the formula, it will get us the same answer. So yeah, that's just a simple proof on why the formula works. So yeah. So yeah, this is our perfect square formula for addition, and then there's also one for the same thing, except you're subtracting the two terms in the middle of the polynomial, and the only thing that changes is that it's x squared, and it's now minus 2ax plus a squared. Only this term changes from plus to a minus. Okay, now let's solve some problems using these three formulas that we learned. We learned about the difference of two squares and perfect squares. Okay, so our first question is, what is x minus 5 times x plus 5? Okay, so this looks like a difference of two squares formula because we have our polynomial we have our polynomial x minus 5, and then we have its conjugate, and we're multiplying those two. So if we use the difference of two squares formula, it should be the first term squared, so x squared, minus the second term squared, so minus 25. And yeah, that's our answer for this question. And now let's try the next problem, which asks what is 2x plus 1 squared. Okay, so this looks like a perfect square product. So if we use the formula over here, we have our first term squared, so 2x, and we want to square that, plus 2 times our first term, 2x, times our second term, 1, plus our second term squared, which is 1 squared. And if we just evaluate this further, we have 2x times 2x, which is 4x squared, plus 4x plus 1. So that's our answer for this question. This is how special products can help simplify our multiplication of polynomials process, and also how FOIL works. So thank you for watching.